Greetings. I'm going to discuss and talk about our enhanced nano spray and microspray LCMS capabilities using our automated heated dual column source. The source provides increased sample throughput and convenience. First, when you talk about high throughput with nanospray, you need to approach the clogging of columns and emitters, because that's unacceptable when you're talking about high throughput. So our core technology has been and continues to be our robust clog-free spray emitters. These are both a patented polypropylene nozzle as well as tapered capillaries and columns with a polymer frit. And the chromatogram on the bottom shows a peptide digest that was performed with one of our nozzles, indicating exceptional performance. What separates us from other emitters is the fact that we just do not clog. Our Micro Auto Nano LC dual column source, shown here on an LTQ Orbitrap with our column heaters, is designed to analyze one column while second column is equilibrating, thus increasing your throughput. In order to do this, there are active spray controls for the spray necessary for the equilibrated column as it moves forth in front of the MS inlet to begin an analysis. And most important is a design that does not add any post-emitter dead volume that would cause band bonding for your peaks. A simple example is shown here where two chromatograms of 15 minutes each require essentially the same amount of time to equilibrate. So 50% of your time is spent waiting in front of the mass spectrometer for the column to equilibrate. With a dual column system, you take advantage of that time to move to a second column and perform an analysis, eliminating the dead time or the wait time before the mass spectrometer and essentially doubling your throughput. All our automated systems come with programmable high voltage. The programmable high voltage allows you to do HV gradients, also comes with tip guard technology that lengthens the nanospray emitter life and is available as a standalone product. Applications can range from optimal spray performance throughout your LC gradient, so as your LC mobile phase composition changes, you can change your voltage going through to maintain an optimum spray. Oligo analyses in high buffer concentrations, and then if you have analytes that have specific voltages for optimum sensitivity, they can be tuned throughout your LC run. Our Nano LC column heaters provide improved sensitivity, resolution, analysis time, and reproducibility. They also reduce the back pressure and reduce carryover. An example of the use of the column heater is presented here with a conventional LC pump with a splitter. And on this is using a 3 micron particle size on a nano column, in which at 4,500 psi, only 170 nanoliters per minute could be obtained. As you can see from the analysis of these 3 neuropeptides, the peaks are late eluting, they're broad, asymmetrical, and not well resolved. By adding heat up to 60 degrees C, the flow is now at the same pressure at 300 nanoliters a minute, and now we have sharp, well-resolved, symmetrical peaks. This is also very powerful if you want to reduce the size of the particle that you're using in your columns to take advantage of the power that you get from the small particles, yet that will increase your back pressure. So by applying heat to your column, you can reduce the back pressure and use smaller particles on a system, more conventional, non-ultra high pressure system. So in summary, our innovations provide improved throughput through our dual column source. We also have direct injection sources, which I've not presented here. And the unique technologies that I've presented today are nano column heaters, programmable high voltage, the active spray control, our clog-free spray nozzles, and tapered fritted capillaries and columns. Our software is well built, very intuitive, and we offer excellent instrument and application support. And we have a source, a dual column source, column heaters, and our emitters at our booth in the foyer downstairs right across the main ballroom. And thank you.